In this video, we're going to look at the derivatives of parametric equations. So remember, with parametric equations, we have x defined as a function of some parameter, in this case t, and y defined as some other function of that same parameter t. So we might want to know, how is x changing with respect to time? How fast is x changing with respect to time? And how is y changing with respect to time? And how does that relate to how y is changing with respect to x? Because when we graph this out, when we graph a parametric equation, we have our x-axis and our y-axis, and we can look at the slopes of those tangent lines in the same way that we always have, and we can look at dy dx in that case. So how does dy dx get determined from dx dt and dy dt? That's the question. Well, we already have a relationship between these three values with our old friend, the chain rule. All right, so let's see if we can arrange these in a way that makes sense with the chain rule. Dy dt, that's going to equal dy dx, can you see it, times dx dt. Okay, we have this relationship from the chain rule. If y is a function of x, and x is a function of t, we have this composite function relationship here. Then the derivative of y with respect to t is going to be dy dx times dx dt. This is your chain rule part right here. All right, so we already have this relationship from the chain rule. Now, what we want to do is we want to look at what is dy dx in terms of how our parametric equations are changing. So all we have to do to solve this for dy dx is divide both sides by dx dt, and so we get dy dt over dx dt. And this is how we find how y is changing with respect to x when we know the parametric equations of x and y. That's a pretty handy little formula right there. All right, let's look at an example. So let's say I'm going to look at a particular parametric equation. Let's say x is equal to t minus t to the negative 1, and y is equal to 2 plus t squared. And I want to ask the question, what is dy dx, or at what point is the slope of the tangent line 1, say. Let's do that. Or we could find the equation of the tangent line. Let's do that. That adds another little step to it. Find equation of the tangent line let's say when t equals 1. Let's do that. At some particular time, we can look at our graph and we want to know the equation of the tangent line when t equals 1. All right, so the first thing we're going to do is we're going to find an equation for our derivative. So we know that dy dx is going to equal the derivative of y with respect to t. Well, that's easy. We have this right here. All right, so the derivative of y with respect to t is just the derivative of this, because it's already, the variable is already t, so we have 0 plus 2t. That's 2t. And then the bottom is the derivative of x with respect to t. So the derivative of this is easy power rule stuff here. So we have 1. Negative 1 times that is going to be a plus, and then we'll reduce the exponent by 1, and we have our formula here. All right, so if I want to find the equation of the tangent line when t equals 1, I'm going to need to know the slope, and I'm going to need to know the point of tangency, right? I need to know the slope of the tangent line at t equals 1, and that point of tangency. So here's my equation for the slope. So at t equals 1, the slope is going to equal, dy dx is going to equal 2 times 1 over 1 plus 1, which is 2 over 2, which is 1. All right, little coincidence there. We could find it at another t. You know, when t equals 2, it's going to be something different. What would it be? It'd be 4 over 1 plus 1/4. So 4 over 5/4, higher mathematics, 1/5, something like that. Okay, so what about the point of tangency? We need some point of tangency to get our equation. So when t equals 1, all we have to do is plug 1 into our equations up here. So x is going to equal 1 minus 1 to the negative 1, that's 1 minus 1, that's 0. And y is going to equal, when t equals 1, 2 plus 1 squared, that's 3. So my point of tangency is 0, 3. Well, we certainly know how to find the equation of a line if we have a slope and a point. And we kind of lucked out here. Our point of tangency is actually the y-intercept. So we can easily write our line y equals 1 times x plus 3. That would be the equation of the tangent line when t equals 1. Let's get a picture of this. All right, let's kind of take a look at what's happening here. Yeah, let's start with this. So on Desmos, if you want to graph a parametric equation, you write it like this. You write it as an ordered pair, and you put for your x component, you put your function for x in terms of t, and your y component, you put your other function, right? And then I just set up this, it asked me if I want to do a slider, so I said yes, and then I set this up because it's kind of cool to see the direction. I'll show it you without the slider. So here's t going from, I just did -5 to +5, but we could let it be anything. It kind of goes off the screen. So when t is negative, it's doing this direction. When t is positive, it's increasing, right? When t is starting at -5, it's decreasing. And then when t hits 0, it starts increasing when the time is positive. So we're looking for when t equals 1. Now we can't see the whole curve here, but I'll show you the whole curve. So here's when t equals 1, which we already calculated was the 0.03. All right, here's what this graph looks like without the slider. So our point was just moving along here. And we're trying to find when the slope of the equation of the tangent line when t equals 1, which we knew was here. Now, if we would have just looked at this point, you know, we might have thought, well, which direction are we going here? Because there are 2 points of tangency there. But when t is 1, the slope came out to be +1, right? So we have y equals x. Why my caps lock must be on? Y equals x plus 3. That was our line, right? So that's when t equals 1, we get this point right here. Now, maybe a more interesting question that might have been asked is, find the equation of the lines tangent to the curve at the point 0,3. And then you're thinking, okay, well, but then you look at the graph and you see, oh, well, there's actually 2 times when that curve hits the point 0,3. So now I have to find 2 tangent lines. And now I need the times where it hits the point 0,3. And if we go back and we look at this one, we could kind of see, you know, we're looking for when does it hit this point 0,3, and we're kind of watching the timer there. It looks like about right there, about -1 and then +1. Let's look one more time. Here comes, I could pause it, but right there, -1 and come +1. All right, looks like -1 and +1. So algebraically, how would we figure that out if we didn't have our good old Desmos with us? Let's go back to our PowerPoint. Okay, so let's say I want to find the equations of the tangent lines when it is at the point 0,3, and I need to figure out the times. Well, we could use either one of these equations to figure it out. We know our x value is 0 and our y value is 3, and we want to figure out when that's going to happen. Just for fun, let's do both, but you wouldn't need to. All right, so let's say I put 0 in for x and I want to solve this. So t to the -1 is 1 over t. Maybe I'll multiply everything by t. Now you want to be careful about multiplying everything by t because I don't want this to be 0, but if t is 0, this isn't defined, so I'm not worried about t being 0 in this case. So I get 0 equals t squared plus, did I write that down wrong? Is that a minus? Yes, I did. I copied that wrong from the other problem, or from the other slide. This was a minus in our original problem here that we're doing, which is actually going to make it work now. Okay, so when I multiply that, I get -1. Otherwise, you know, when I had that +1 there was going to be imaginary solutions, and I knew that was no good. Subtract that over, take the square root of both sides, we get plus or minus 1, which is exactly what we thought, right? By looking at our decimals, we saw that it looked like two different times, probably t equals 1 and t equals negative 1. If we'd have put the 3 in for y, this one's actually a little faster, and it should come out to be the same thing, okay? So then what we would have had to do is, split it up and say, okay, we've got t equal 1, t equal negative 1. I need to find the slopes at those two different times, so we would figure out our derivative formula, which we already did, which was 2t over 1 plus t to the negative 2. And we already did this one, and then you would just do this one the same way, right? Except for this one, your slope would be 2 times negative 1, which is negative 2, over 1 plus negative 1 to the negative 2. So this is just going to square it and flip it over, so it's going to make it a positive, so it's going to be 2. And my slope is negative 1. So we could see from this guy, there's our 1, so our other line is going to have a slope of negative 1, and it's still going to go through the point 0, 3. So there we have our two tangent lines. All right, I hope this video helped with parametric equations and finding the derivative. The main takeaway is this guy here. Resulting, our old friend the chain rule, resulting in this formula right here. So if you can remember the chain rule, you can remember the formula for derivatives of parametric equations. And then, parametric equations have some different things going on. You might have two lines tangent to the curve at a given point. So it can get a little more complicated than what you're used to.